Hey y'all, my name's Hudson, and I am going to be talking about the Carboniferous Period. So, the Carboniferous Period started around 359 million years ago and ended around 299 million years ago. So, that's a big chunk of time, 60 million year period. Obviously, after watching the video from the short quiz we took, doesn't seem like a ton, but when my little brain thinks about it, that's obviously a ton of time. So, to talk about the Carboniferous period, basically, the world had a large influx of oxygen, making both plants and insects abnormally large in size. So, there were dragonflies that had 2.5 foot wingspans. Um, I would not know what to do if I ever saw something like that. It would be jarring and terrifying all at the same time, but kind of cool, and it's kind of fun to look at when you're not living in the middle of it. Another thing that's been recorded in some fossil files is 8 foot long centipedes. Disgusting, terrifying, but still really cool when you're not living in the middle of it. Um, so when we talk about the geology of the Carboniferous period and like where we kind of get a feel for the time, we mostly look at the coal, like these coal seams that are made up of these fossilized swamp plants. So a lot of our coal deposits in the world come from this time, from the rapid death of tons of vegetation, specifically ferns and lysopods. Um, Obviously, extremely beneficial to what we do today and what we did within the past 100 years. Coal has obviously been a big industry and done a lot for this world as far as energy goes. So that's something really cool. And then we can also look at fossils within these layers or seams of coal, and we see a lot of the evidence of those insects. Um, and so, yeah, we get a good sense of what was around physically, or as far as animals or bugs go. And then we can also see the amount and the type of plant based on the large deposits of carbon. So, a lot of the evidence for this event is it's found all over the world. This was obviously not just America, not just Arkansas. This happened globally. So there's evidence for it everywhere. But more specifically, there's a lot of evidence in the eastern United States, the UK, Germany, Russia, and China. Um, so we see a lot of that, and that kind of answers the question of where is this evidence found. To give you a better scope on the world besides these giant bugs and large plants, the world was very warm and humid at the time. Obviously, great condition for the plants and for these insects to thrive, as well as when talking about continents and what the globe looked like how you would draw it out. We were very close to Pangea. So we weren't all the way there. The world was, or the land in the world was, closing in, and we were getting really close. There's still just a little bit of a gap. So kind of right before Pangea is kind of the time frame, kind of what the world looked like, and it was a very warm and humid climate. Again, this also helped produce these super large ferns and lysopods that you see in examples from the time period. Um, some really cool facts I learned while doing some research on this, and I was really curious about how the bugs got so big. Um, it's pretty obvious. Again, it was high oxygen content in our atmosphere. We were sitting at like 35%, and modern day is around is 20.9%. So a large influx of oxygen, which led to obviously large plants, photosynthesis. They need oxygen to grow. Unfortunately, also a lot of forest fires. It's very easy for forests to catch a blaze with all that oxygen. Look at the fire triangle if you're confused on that. You need oxygen for fire. But the reason the insects got so massive is because, one, insects don't have lungs, or they didn't at the time. I don't think they still do, based on what I've read, but I haven't fact checked that. With more, so they would basically absorb the oxygen through their bodies through these small openings all around their body, and so with a more efficient oxygen exchange, it basically allowed them to grow to such a size. It gave them the capability to do such things. And then during this time, the development of the amniotic egg began. So that's obviously really important when we're looking at evolution. Um, it basically allowed vertebrates to reproduce away from water, and so that's kind of the start of land species. Besides obviously these bugs, they were flying around on land, but they might not reproduce on land. So that was obviously very crucial to evolution and paved the way for kind of how things are today. I'm sure all these periods paved the way in some way, but I think I got a pretty interesting one. So I'm excited to learn what you guys have to say. I hope you guys got a little bit of information out of that, and thank you.